Hello and welcome to this video where we're going to be looking at the gradient between 2 points. So you can see I have 2 points here on the screen, A and B. And if you were to imagine these on a coordinate grid, they'd look something like this. So you have A down here, and then over here you have your second coordinate, B. And what we are going to do to work out the gradient between these 2 points is we're actually going to look at the change in the y coordinates, and then we will divide that by the change in the x coordinates. And so you can see B is out here at 3, 7, and A, in my case, is at 1, 3. And so the change between the two y coordinates, you are going to do this y coordinate here, 7, and you are going to subtract this y coordinate here, 3. 7 minus 3 is 4, so that's the change in y. And then we are going to divide by the change in x. And so this x coordinate here is at 3, this one is at 1, and so if I do 3 subtract 1, that is 2. So the change in the x coordinates is 2, and so we are doing a division of 4 divided by 2, which is 2. And that's the gradient between the 2 points finished. Okay, so if you understood that, please feel free, pause the video and see if you can have a go at this problem here that I put up on the screen. I will display the answer in just a minute. Okay, so if you tried that, you should have done something like this. So you have change in y divided by change in x, which is 10 minus 1 over 7 minus 4, which is 9 over 3, and then that simplifies down to just 3. That is the answer you should have got. Okay, so in general, we can write this as a formula. I was looking at that as the change in the x divided by the change in the y. You can also write this as y2 minus y1. So that's the second y coordinate subtract the first y coordinate divided by x2 minus x1. So that's the second x coordinate divided minus the first x coordinate. Okay, so we can do this more formulaically with this one. So this here is going to be x1. This here is going to be y1. This here is going to be x2. And this here is going to be y2. And so now I'm going to carry out the division. So we have y2 minus y1, which is 1 minus 4, over the change in x, which is now x2 minus x1, which is 3 minus 2. So 1 minus 4 is going to be negative 3. 3 minus 2 is just 1. And negative 3 divided by 1 is just negative 3. Now let's look at a second problem. So here I have a different coordinate. So I've introduced some negatives here. This is still going to be the first x coordinate. This is the first y coordinate. This is the second x coordinate, and this is the second y coordinate. So looking at the change in y, that's x2 minus x1. So this is 4 minus, and now I need to subtract negative 2. So it's going to be minus minus 2 over. And then I am going to do negative 3, which is x2, minus x1, which is 5. So 4 minus minus 2 is going to be 4 plus 2, which is 6, divided by 3 minus 5 is negative 8. So this doesn't simplify down very nicely. We are still going to have a fraction, but I can simplify this a bit because I can divide both of those numbers by 2. So 6 divided by 2 is 3, minus 8 divided by 2 is negative 4. So this is minus 3 over 4, minus 3 quarters, or you could write this as minus 0.75, but both are absolutely fine. Okay, so here's some problems for you to have a go at. You have two problems here, question 1 and question 2, and both will involve some negatives in some way. So again, you can pause the video and have a go at these two yourselves. Okay, so if you did try that, you should have an answer like this. So for the first one, the gradient is 8 minus 4 over 1 minus 3, which simplifies down to negative 2. And in the second question, you have the gradient as being minus 3 minus 7 over minus 6 minus minus 1, which simplifies all the way down to 2. So if you did manage to get negative 2 and 2, congratulations. If not, feel free to pause the video again and just look through and see how I've worked it out. Now you might notice here that I've actually called the gradient here m, This is just the standard letter that we use for gradient. So we will call the gradient m, and in a later video, if you watch my video on the equation of a straight line, you will see that actually it's y equals mx plus c. This is the full equation for a straight line where m is the gradient. This is just another letter that we use to mean gradient. Okay, the last thing to do is have a look at a problem solving question. So here we are told the gradient of AB is 2 over 3. And then I'm given the 2 points A and B, but I have this missing coordinate here. The x coordinate of B I do not know. And so what we can do is we can substitute into the formula that we've just learned, the change in y divided by the change in x, and see if we can solve this to work out what that unknown x is. Now I know that this gradient thing here is going to be 7 minus 3, so the 2y coordinates subtracted, change in y, over, and then I have x minus 2. So this minus this. And this is equal to the gradient that we've been given, which is 2 over 3. So we can just simplify the numerator first, because 7 minus 3 I know is 4. So this is 4 over x minus 2 is equal to 2 over 3. Now there's two different ways you can now approach this. What you could do is take the denominator here, multiply up and solve for x. That will work perfectly well. Or actually I think what I will do is just change this fraction. So I can change this fraction if I times the top by 2 and the bottom by 2. Then this fraction becomes 4 over 3. So I have 4 over x minus 2 is equal to 4 over 3. And so now you can see that the numerator is 4 in both cases. And so actually x minus 2 must be equal to 3, in which case x must be 5. And we are done. Thank you very much for taking the time to watch my video. I really hope that that was helpful for you. If you did find it helpful, then please feel free to give the video a like, and it will help other students such as yourself to find this video. I will put a link in the description to some other videos that I've done that are to do with straight lines. So the equation of a straight line, finding the midpoint, and also parallel and perpendicular lines. I hope you have a great day.